All right, let's talk about the power of certain words. Not just any words, but these special scientific and, well, speculative terms that just seem to grab hold of our imagination and not let go. I mean, really think about it for a second. Why do some words just hit different? When someone says black hole or wormhole, doesn't a part of your mind just go, whoa? It just lights up with all these possibilities, a sense of awe, maybe even a little bit of a thrill, right? And that is exactly what we're going to dig into. It's like there's this whole category of concepts, born from some pretty heavy science that are just irresistible. They hook our curiosity and just don't let go. So yeah, let's get into it. Okay, so first up, journeys through the cosmos. We're exploring the grand scale of the universe. And when I say big, I mean really big. We're basically taking a trip to the very edge of space and time to look at the words we've come up with to even try and describe the sheer scale of it all. And you really can't start any bigger than, well, the beginning of everything, right? The Big Bang. It's so much more than just a theory, isn't it? It's kind of our collective origin story, this single unbelievable point that just exploded. And from it came all of space, all of time, all the stuff that makes up everything. So, okay, we've got this gigantic universe. How in the world do we even begin to make sense of it? Well, the rule book, the instruction manual, is Einstein's theory of general relativity. And what it tells us is pretty mind-blowing. It says that huge objects like stars and galaxies don't just pull on other things with gravity. No, they literally bend and warp the very fabric of reality, what we call space-time. It's basically the operating system for the entire cosmos. So what happens when you take those rules and just push them to the absolute breaking point extreme? Well, you get a black hole. We're talking about a point with so much gravity packed into it that space-time just collapses. It breaks, and nothing, not even light itself, can get out. It's a genuine monster of the universe, and what's wild is that it comes straight out of the math in Einstein's equation. But general relativity also hints at something else, something even more out there, more speculative: the wormhole. This is the idea of a theoretical tunnel cutting right through space-time, a cosmic shortcut, if you will, that could, in theory, link two super distant points in the universe, or maybe, just maybe, connect different universes altogether. Okay, now this is where it gets super interesting. You've got this cosmic speed limit, right? Light speed. It's the law. Nothing in the universe goes faster, period. But then, hiding in the exact same set of physical laws, you have this idea of a wormhole, which is basically a potential loophole. It's the perfect example of how science draws a hard line in the sand and then immediately whispers, but what if there's a way around it? All right, Section 2, Hacking Reality's Code. We're peeking behind the curtain of existence. So we've done the whole macro cosmic scale thing. Now, let's do the complete opposite. Let's zoom way, way in. We're going to try and peek behind the curtain and check out the weird, beautiful, and downright strange ideas about what reality is actually made of at its most fundamental level. And one of the most famous candidates for this is, of course, string theory. The basic idea here is that if you could zoom in on any particle, like an electron, way past what we can see, you wouldn't find a little dot. You'd find a tiny, vibrating filament of energy, a string. And just like a guitar string can play different notes, the different ways these tiny strings vibrate are what create all the different particles and forces in our universe. Kinda cool, right? Now, the set of rules for this tiny, tiny world, that's quantum mechanics. And seriously, you have to throw everything you know about common sense right out the window. Down at this scale, particles can be in two places at the same time. They can be linked or entangled across the entire universe, and the simple act of observing something can actually change what it's doing. It is bizarre, it's mind-bending, but here's the kicker: it absolutely works. So this quantum realm is where we find the fundamental building blocks of, well, everything. You've got fermions, which are the particles that make up all the solid stuff. You, me, the device you're watching this on. Then you have predicted particles, like the graviton, which is thought to be the particle that carries the force of gravity. And by figuring out how to control these weird quantum rules, we're now building things like quantum computers, machines that could solve problems that are literally impossible for even the most powerful supercomputers we have today. And this is a great way to see how our understanding just completely evolves over time. We used to believe in this thing called the ether, this invisible substance that filled all of space and helped light travel. We know now that's just not true. Instead, our modern ideas are built on some seriously strange math, like George Cantor's work on infinity. I mean, he proved that some infinities are actually bigger than other infinities. It just goes to show the tools we use to describe reality just keep getting weirder and a lot more powerful. But even with all these amazing tools and theories, we're still staring down two of the absolute biggest mysteries there are: time and consciousness. We live inside them every single second of our lives, right? But a real, complete scientific explanation for what they actually are, that's still one of the ultimate holy grails of science.
Okay, next up, science meets imagination. This is where facts inspire fantasy. And now we're really getting to the core of it. We've talked about all these incredible scientific ideas, so now let's look at how they become the jet fuel for our wildest imaginings. You know that point where solid science becomes the launchpad for pure fantasy?
I absolutely love this phrase, nonsense concepts. It sounds kind of harsh, right? Like you're dismissing something. But that's not it at all. These are those big, speculative, what-if ideas that are the absolute bread and butter of science fiction. The thing is, they don't just appear out of thin air. And here's how it works. You can draw a direct line. You take general relativity, with its warping of space-time, and that becomes the scientific seed for stories about portals to other dimensions. You take the strangeness of quantum mechanics, where everything comes in these little packets, and that sparks the idea that, hey, maybe our whole universe is made of pixels. Or you look at computer science and how far we've come, and that leads to the ultimate nonsense question. What if our reality is just a simulation? See? They're all connected. And that's really the magic of it, isn't it? That blurry line between science and science fiction, it's not a wall separating them. It's a launch pad. It's the place where we take everything we know for a fact and use it as a springboard to dream about everything that could be. All right, final section, the language of wonder, bridging knowledge and imagination. So let's wrap this all up. What is the real power behind this language of wonder we've been talking about? Well, it's all about building a bridge between what we know and what we don't. Because it's pretty obvious by now that words like black hole or quantum or infinity, they're way more than just technical jargon for scientists. They're like cultural artifacts. They've become shorthand for some of the biggest, most profound ideas our species has ever tried to wrestle with. Yeah, they're like tools for our minds. I mean, for a physicist, sure, they're precise labels for really complex stuff. But for the rest of us, they're like handles. There's something we can grab onto to even try to get a grip on how huge and mysterious the universe is. They give us a way to talk about the absolute edge of what we know. And really, if you take one thing away from all of this, let it be this. These powerful, attractive words have a super important job. They create that bridge we were talking about. They connect the solid ground of what we've proven with the wild, open, boundless frontier of what we can imagine. And that leaves us with one last, really fun question to think about. Remember, the idea of a black hole was once just a crazy theory on paper, a nonsense concept for a lot of people. So, if you look at the science fiction being written today, which of those wild nonsense ideas is just sitting there waiting for that one discovery that'll turn it into the real science of tomorrow? Something to think about. Thanks for joining us.